Okay, so we figured out that the clear colorless solution with a violet colored flame is probably potassium. So, Dan.
It could be with sulfur 2 minus.
Could it?
It says no. Yeah.
But what does it say about group 1 metals? It is impossible. Look at this. All group 1 metals, blue means they dissolve in water. So anything with a group 1 metal is going to be soluble. You got to read the fine print. It says at the bottom of the top line in your solubility tables, it says all group 1 metals and ammonium ions are soluble. So your precipitate does not contain K+. What metal does it contain? What metal does it contain? Mercury. You add HgNO3, and I'm assuming it's HgNO3 too, but it didn't say. So therefore, the potassium had to be, you can't just say, oh, I'm going to make a solution of potassium ions. There has to be a negative ion that went with the potassium. So there has to have been a negative ion with K+. So give me something that will precipitate out with mercury 2+. Dan, you would like to look at this. Okay. Jovan. That's mercury 1+. No, Hg2, 2+, is the same thing as Hg1+, which is why it's in brackets, Hg1+. Mercury is a weird substance when we write the formulas, yeah.
I thought it was burning. So shouldn't it be with oxygen?
No, we're not burning it.
Okay.
No. Okay. All of these will form a precipitate with mercury 2+ ion. All of them are going to be soluble if they go into solution with potassium. So if you had dissolved K2S, KOH, K2CO3, K3PO4, K2SO3. These would all precipitate out the mercury compound. So you would make mercury 2 sulfide, mercury 2 carbonate, mercury 2 hydroxide. Make sense? If it doesn't, you've got to speak now because I'm not going to guess what's going on in your mind. It's impossible for me. You've got to communicate with me. Yeah. Okay. Okay, do me a favor. Listen. Don't have side conversations. I've got potassium and some negative ion. We'll call it A. Because we don't know what it is. There's nothing in the periodic table that is A. So, potassium and some negative anion, right? An anion is a negative ion. So we have this floating around in solution. We add a beaker of mercury to nitrate. Is it soluble or is it a solid? Look at your solubility table. Mercury to nitrate. It's AQ because all nitrates are soluble, right? All of them. So we've got this. So what's going to happen here when we mix them? You're going to get this solid at the bottom, and it's mercury connected to your ion, A, negative, and we're still going to have K plus and NO3 ions in solution. What are your spectators? What are the spectator ions? Yep. K plus and NO3 minus are your spectators. What are your ions that are going to be in your net ionic equation? Yep. Your Hg 2 plus and your A negative. We don't know what the charge is on negative, so I just made it 1. Okay? You're picking what A is. That's what it's asking you to do. Pick A from here. What precipitates out with mercury that doesn't precipitate out with potassium?
Can we use X instead of A?
You could. Okay? I only picked A for anion.
Oh, okay. Yeah.
Okay? Got it? Want another example? So I want you to identify and what X is and a possibility for A. Could A be SO4? Yes. What else could it be? Abderrahim. No. Look at the top. Yeah. Jovan. Nope. Cannot be S2 minus. Why not? Look at the top. Group 2 metals are soluble. Strontium's a group 2 metal. Got to look at both top and bottom. This is good. So, A minus could be sulfates. It could also be carbonates, phosphates, and sulfites. Because they are the only substances on this table that precipitate out strontium. Okay? Yeah. OH, it says at the top, Sr2 plus is soluble. Gotta pay attention. If the top or the bottom says most, check the other half to see if your substance is in there. Okay? Yeah. S2 minus, it says group 2 metals are soluble. Right? It's in the second column, so it can't be group 2 metal. X is sodium, so we know sodium doesn't precipitate out with anything. Are you seeing a pattern here? So sodium doesn't precipitate out with anything, so your precipitate must contain barium, because it has to contain a positive ion. So we know this solid is barium something. We know it's not barium nitrate because that's a solution, and all nitrates are soluble. So A negative, the negative ion, has to precipitate out barium 2 plus. So look, what will precipitate out barium 2 plus? Give me one. SO4 2 negative. Stephen.
CO3 negative 2.
Carbonates. Yovan. Who? PO4? PO4 3 negative. Give me another one. SO3 2 minus. Sulfite. Okay. Any one of those you give me is correct. So my precipitate will be one of these with barium. That makes sodium and nitrate the spectator ions. Your mom.
Let's say the question was on text, right?
Yeah.
So, would the question be to find one of them, or do you want, like, let's say, all, like, would the question look different? Maybe you want one of them, or all?
I might ask a question, if I mix these two things, which one will give me a precipitate? Or it might be exactly like this, but I would have to give you a table with the information on colors and solutions, except for Michael. Okay? I would have to give you that information. I would never ask you to memorize data from a table. That's a waste of your brain space, a waste of your energy. This information will be in any reference textbook. Okay? It's better that you know how to use it than what is actually in it. There have been questions, though, where we do it backwards. You have to identify the negative ion first.
Can we do an example?
No, they're a little harder.
What?
They're a little harder. Okay? So I'm not going to give you
Like you're not going to show us?
I'm not going to give you that question. It would be like this, positive ions. Okay. I have not yet talked about the back of the first page of qualitative analysis. You were supposed to fill in the blanks. For the front page. Okay. So you can identify whether something is present based on observations, right? That's qualitative analysis. Observations, color of solution, color of flame test, pH readings, bless you, or the color that litmus paper turns, conductivity, if it conducts electricity or not. Usually that's a stick this reader in the solution, it either beeps or a light flashes if it conducts electricity. But of course, you got to have it hooked up to some source of electricity, like a battery. Precipitation is another qualitative analysis. If I mix these two things together and I get a yellow precipitate, I check what could possibly give me a yellow precipitate. Chances are you know one of the ions, either the negative ion or the positive ion, okay? Often this is how we identify whether a substance is present, and it's a sequential kind of lab. When I was in an undergrad, we probably spent maybe 4 lab periods, that's 12 hours. We had a mixture, and we had to figure out which ions were in it. And there were like about 7. So our lab mark was based on our procedure that we had to make up, and our observations and our results.
How'd you do it?
I went to a textbook and I read how to do qualitative analysis, and then I set up my lab from there. And I'm going to show you how to do it if you've got 2 ions. I need to hand out. Thank you. Okay. Oh my gosh. Qualitative and quantitative analysis. Here we go. All right. So this was on the 2nd page. It was number 6, right? Qualitative chemical analysis. So when you do this, usually you're told you have a beaker and you have no labels. You should be okay with this because you just spent the last half hour on these kinds of questions. Okay. So, with a beaker, and you'll know there's an ion or 2 present. And it will ask you to identify. What are you going to do if you're told that it could contain potassium or sodium ions? It could contain potassium or sodium. What could you do to test it?
Put in like different types of ions in specific forms, or discrete forms, like make it so that it will only form with one of the ions.
Ah, but these are both group 1 metals. Brandon. Flame test. The only thing you can really do if you've got 2 group 1 metals is a flame test. And you're going to look for colors, but the problems sometimes with colors, if one is stronger than the other, it's more intense, it can mask the other. So if you've got a slight, it's a light purple or violet flame, you know that it is potassium. If you have a bright yellow flame, you know you have sodium ions.
That's pretty much all you can do. It's a flame test. We're going to do flame tests next year. Okay. Oops. Does your note have an example yet? Oh, you did. Okay. Let's say we've got a beaker and it could contain copper 2+ and iron 3+. Okay? Could contain either one of these ions. What could you do? Yeah?
Look at the color of the solution.
Look at the color of the solution. What if it's green?
Green. Then if there's green, there's both.
There's probably both of them. One way to double check for sure is to do a solubility test. When you do a precipitation reaction, your first thing you're going to pick is something that will precipitate out only one of those ions. So you're looking for a negative ion. You're looking for a negative ion that will precipitate out only copper 2+ or only iron 3+. So look at your solubility table. Is there anything? No. So could you do a solubility test on this? Okay, let's try this one. That's it. You just have to look at the colors. What if you had copper 1+ and let's do iron again. What if you had copper 1+ and iron 3+? Why? You've got calcium, and if you don't, there's no calcium.